All right, everyone, this lecture will be about solar power for AP Environmental Science. Solar represents one of our learning objectives. We're going to talk about how we harness energy from the sun for solar energy and what impacts that has on the environment, both positive and negative. Here's the vocab that I'm going to skip. And getting right into photovoltaic solar cells. So I'm going to just say photovoltaic cells, but AP has them written as photovoltaic solar cells. These use light energy from the sun to directly generate electricity. You guys don't need to know how they work. You don't need to know all of the different types of solar cells that we see up on the top right. But essentially, electrons within those solar cells are going to become excited, and they're going to get excited by light, and just depending on the material that is, usually crystallized silicon, and those moving electrons are going to be your electricity. Okay, um, those cells can be very, very small. So like think about the one that might be on your calculator, or they can be very large and aggregated into solar panels. You're not going to really see the term photovoltaic modules, but typically solar panels. And those solar panels can be in solar fields. They can be mounted on homes. They can be freestanding outside of homes. They can be on or municipal buildings or businesses, whatever. This is a variable energy source because it only is going to generate electricity when the sun is shining. On cloudy days, if it's just a little bit cloudy, you're going to get some electricity produced. If it's like very dark overcast, you might not get any electricity, but maybe some. It's really at night when you'll get zero, and then on a cloudy day, you'll get a minimal amount of electricity, and then on a sunny day, you're going to get the full potential of electricity. And there is no emissions of any gas, any waste gas during their use or during their operation. So most solar cells are going to last for about 25 to 50 years. That can depend on the quality of the panel itself and the climatic conditions. If there's a lot of hail in a region, they're definitely going to last a lot less time. And if there's, you know, never any hail, never a sandstorm, never anything like that, they're going to last a little bit more. However, the efficiency is going to decline throughout their functional lifespan, and some components may become waste or become recycled, just depending on what happens to the solar panel at the end of its lifespan. Some materials are very easy to recycle in a solar cell. Some materials are very, very difficult, and it's very difficult to separate all of those materials so that you can even recycle the ones that are easily recyclable. All right, so the next type of solar energy that we're going to talk about is concentrated solar power, or abbreviated as CSP. This is going to use any type of mirror or reflector or lens to concentrate sunlight over a large area down to a single point. And that single point is going to heat up water, which is going to turn to steam. Actually, typically, most of the time water, but it can use some other fluids, including like ammonia or other fluids, but for our example, just water. So it's going to heat that water, turn it to steam, which is going to turn a turbine, which is going to turn a generator, which is going to generate electricity. So if we look at the picture up at the top right, this is a series of mirrors all pointing to this one point up here where there is going to be a reservoir of water. That water from all of those mirrors shining all of the sunlight directly at it is going to heat that water up super hot, going to turn it to steam, which is going to be sent down here to the turbine, and that's going to be hooked to a generator, which is going to generate electricity. Okay, we have a different type over here at the bottom, which is modeled in the middle diagram down here, where we have all of these collectors that are concave lenses, and those are, sorry, concave mirrors, and those concave mirrors are all have a fluid going from this pipe up to them, and right up here you might be able to see that fluid or those pipes with the fluid in it, and it's going to do basically the same thing, concentrate solar energy right at that pipe with that fluid, heat up that fluid into a vapor, which is going to be sent back to a turbine to generate electricity because it's hooked to a generator. And then I don't have a picture of this other one down here, but you could have a large mirror that sends it to a single point that is almost attached to the mirror, kind of like the one down here. Now in terms of energy storage, solar is a variable energy resource, so we can't generate a lot of electricity at night. Even if it's like always going to be a sunny day, you can't generate electricity at night. So if we're going to use solar power around a city or for a home, it's best to be able to store that energy or to send that energy back to the grid and for the grid to supply energy for the home while it's nighttime. So let's talk about that first. So let's say that you have solar panels on your house. If you watch the meter on your meter might run backwards because depending on the the power company that you have, if it's during the daytime, you have this home with a solar panel, it's going to generate more electricity than the home's needs, so it's going to send energy into the grid so that that energy could be used throughout all of the other homes and businesses on the grid. Your meter is actually going to run backwards and they will sort of like quote unquote pay you for that electricity. At nighttime though, you will be getting electricity from the grid because you're not getting sunlight for the solar panels, so you're going to be getting electricity from the grid, and your meter is going to be going forward. Other options include batteries, so large banks of batteries, such as what you see along these solar panels. Alternatively, you could have a home that just has maybe a bank of car batteries, like what we see on the bottom right. Or we can pair it with a consistent energy source or use something like pumped hydropower storage, whichever option we decide to do and whichever is best for the given scenario in the given situation. So this is pumped storage hydropower. We talked about this when we talked about hydroelectricity. So I'm not going to focus on this slide too much, but this is an option for storing that excess electricity that the solar panels create during the day and then using that at night. So if you want to read it, go ahead or check out the hydropower lecture. All right, so all of that was solar for electricity. Now let's talk about a couple ways that we can use solar for heating. So the first one is active solar. You can also call this active solar heating. This is going to use different arrays. These are not solar panels, so none of these are solar panels that you see. These are instead these structures that are for active solar. I don't even know if they even have a name. But what they're going to do is pump water into this, and through a series of pipes inside of this, you can heat up water and send that to a tank or send that to a pool or send that to a laundromat or whatever needs hot water. So for example, my neighbor has one of these. He has it on the fence, on the south side of his fence, and it heats up all the water that he sends to his pool so that his pool is sitting around like 80, 85 degrees Fahrenheit during the summer rather than it being like, 50. So he really likes that and it's great. I have one that uses air on the side of my workshop. So I essentially have this big panel and at the bottom there's an air intake from my shop itself. So through the wall of my shop, this is on the south side, and there's a small area right there that the air can congregate. And then I have these, they're just metal gutters actually, downspouts, that everything is painted black inside of it. And these metal downspouts allow the air from down here to go through them up to this top area where there's an entrance into it. So cold air, let's do blue for cold air. Cold air comes in to my shop, in from my shop, let's say during the winter, heats up in all of these black tubes, and then all of this hot air is going to go back into my shop. That air that goes into the shop is like 90, 95 degrees. The air that goes from the shop, from the floor of the shop into this panel is like 30 degrees in the winter. All right, so this is active solar. We're using a fluid, whether that is water, antifreeze, air, whatever it is, to heat up either the air of the home or the building, or to heat the water for that building's use. Okay. A couple other things I should point out is that everything is painted black inside of these so that they collect as much heat as possible. And they're always going to be pretty well insulated so that, at least on the backside, so that it doesn't lose any excess heat that it gets. You want to use all that heat to heat up the water or heat up the air inside of it. And then finally, there is passive solar. So passive solar heating or passive solar building design. This is going to be essentially how we make a home, how we build a home, how we design a home and construct it. We will do it so that we can take advantage of the sun during the winter predominantly, and then cool the home by having shade in the summer. So if we look down at the diagram on the bottom right, we see that this awning of the house or the eaves of the house are at a certain angle that we can calculate or just look at in the summer so that it blocks the sun and this room stays shaded and cool during the summer. But when the sun is lower or the earth's tilt, all that stuff, makes it appear as though the sun is lower during the winter. You can get the sunlight going straight into the home through these large banks of windows, heats up the home. You will have lots of thermal mass, whether that is stone floors or water barrels or anything that can absorb a lot of thermal energy and then slowly release it over time, so that you can heat up this house not just during the day, but all those materials can trap that heat and release it slowly throughout the night so that it stays warm even in the winter. So you see an example of that over here on the left, where it's very intentionally built that way. Up at the top, we have something that's kind of similar, and we can think about it as passive solar heating as well. What we have is essentially like a greenhouse, it looks like, attached to this home, and that's going to absorb a lot of thermal energy during both the summer and the winter that's going to heat this home. So not as good of a design as what we see on the bottom because it's heating it during the summer when we want the home to stay relatively cool, but it is going to be passive solar nonetheless. So when I said large tanks of water, you probably thought like who would have large tanks of water in their home. This is a really cool way to do it in a very artistic and nice looking way. So what these people have is again the passive solar. This is south facing and it's going to probably be shaded during the winter. All of this water, all of this stone on the ground, all of the stone of this fireplace or whatever it is all going to trap the or absorb heat during the day and then slowly radiate it out at night. And in terms of building design, we can design our buildings so that they use all three of these. So this building is a great example of that. You have solar panels or photovoltaic solar cells. You have active solar up here. And you have this passive solar building design where you have these large awnings that are going to block the sun or shade these windows during the winter and then, or sorry, the summer, and then allow the sunlight in during the winter. All right, so getting back to electricity, the global share of the solar market is growing constantly. It's one of the fastest growing shares of the market along with wind. Just in the US alone, it is estimated to be $167.8 billion in 2020. This does not include either active solar heating or passive solar heating. This is just electricity production. One of the great advantages about solar is that all that you need to really get energy or get electricity is to bring some solar panels into a community and hook them up to either batteries, or sorry, to whatever electronics are in the community, but then to batteries and everything to store that energy at night. So you don't need to build a big power plant. You don't need to construct a new hydroelectric dam or a new coal burning power plant or anything along those lines. It's really easy to get solar panel to rural people, especially rural people in very impoverished areas and in developing nations where they otherwise would not have access to electricity. So this can help very easily provide electricity to the estimated 1 billion people around the world that don't have any electricity. So it's great to do when people are quote unquote off the grid, whether that is voluntarily or voluntary or because it's a socio-political or socioeconomic reasons. All right, so I'm going to show a couple maps. You see these same maps in our wind PowerPoint, but I'm going to focus here with them for solar. There are some places in the world that solar is more applicable than others. Solar is going to be most applicable in your desert regions. So look at the outback of Australia, the Namibian Desert in South Africa, the Atacama Desert, the desert southwest of the United States. That's where it's going to be most applicable. Solar is going to be least applicable in some of your cloudiest areas. You're not going to get a lot of solar power in the rainforest, for example. Okay, you're not going to get a lot of solar power up in your very cloudy, temperate, deciduous forest areas. So even though Germany is investing heavily into solar power, it's not really applicable. If anybody's been to Germany, especially during the fall, it is like cloudy every single day. Um, at least during the fall. During the summer, they have some sunlight. But during the winter, their days are super short. They don't have much sunlight during the winter. So what we're really looking at is between these two dotted lines and then the sunniest places around the world for solar and not the cloudy areas like rainforests or up in the really high latitudes. And then this map shows the global wind potential around the world. Now, Germany is very good for wind power. Like they have plenty of potential for wind, maybe not so much solar, even though they're investing heavily in both of them. Some places the wind is going to blow much more constantly. Some places the wind is going to blow much less constantly or not much at all. So I'm not going to focus on this here because this is a solar PowerPoint and not the wind one, and I focus on the wind one, but let's look at them two together. So if we are going to completely transition economies off of fossil fuels to renewables, the two renewables that everybody seems to talk about are solar and wind. And this is where the two are applicable together. So if you have two variable resources, hopefully you're producing electricity with one of them while the other one is not producing electricity, right? Wind at night, or for example. So combining solar and wind might be beneficial, but it does put a lot of strain on the management of the grid. But what I want you guys to look at is where the population centers are. There are some population centers that are super applicable for both solar and wind. Albuquerque, New Mexico would be a great example. But the the eastern cities of China, not such a great example. And if we remove anything that is applicable for both solar and wind with that is outside of 1,000 miles of a major city, because 1,000 miles is a long way to move electricity, we see that we even have less areas that are applicable, right? So the population centers with the little dots, we notice that the about half of the world's population lives just in this circle in South and East Asia. And even though the Philippines and Indonesia are investing heavily in geothermal, how are we going to provide clean, renewable energy to most of China, India, the two most populated countries on the planet? Um, Solar and wind may not be the best option. It might be a piece of the puzzle, but we need other energy sources as well. So this is where I would argue for hydroelectricity or possibly nuclear. Both of those countries have nuclear power, so expanding that. But solar and wind can be a part of the puzzle, but we're not going to get the entire world economy on solar and wind because it's just not 100% applicable everywhere. So I don't want you to misunderstand me and think that I'm not an advocate of solar. I definitely am, and I think that solar is definitely one of the energy resources that we should be relying on, but everything in its place. We live in the real world, and there are limitations everywhere in the real world, and we should just be using the energy resources that are applicable in the places that they're applicable. Right. So let's talk about the environmental impact. We can have habitat loss from large solar fields, especially in deserts, which are very fragile ecosystems anyway and take a lot of time to recover from disturbance. But that could be from grasslands, or it could even be a cause of deforestation to create large solar fields. You guys can probably see on this what maybe was farmland, what maybe was grassland, how much the vegetation has suffered all of these bare areas of soil due to the installation process of the solar field and the heavy machinery and all the workers trampling the soil and everything like that. Um, concentrated solar power, sorry, this should be CSP, requires water as a coolant, so it's going to be used in a lot of water, but they're typically in the desert where water is typically scarce anyway. So where are they getting that water? Typically from groundwater, which comes with its own problems that we've talked about. Um, the materials, basically everything in the material in a solar cell has to be mined, and that comes with its own mining problems. So this is an example of a silicon mine, an open pit silicon mine. We need a lot of silicon for solar panels, especially if we are to expand them at the rate that they're projected to expand and the rate that the IPCC suggests that we need to stay below 1.5 degree Celsius warming, or even 2 degrees Celsius warming by 2100. Manufacturing can expose people to hazardous materials. The recycling process of solar cells can expose people to hazardous materials that are in the solar cells themselves, especially heavy metals. However, the life cycle emissions are very low compared to the fossil fuels. So even though we're going to be using some carbon dioxide or emitting some carbon dioxide through the mining process, the transportation process, the installation, the recycling, the disposal, it's still a fraction of what it is for either coal or natural gas or petroleum. So definitely one of the clean sources of energy, releases no atmospheric pollutants again. And in terms of human health, one of the safest, 0.02 deaths per terawatt hour according to our world in data. That is primarily due to the heavy metals and toxins that that workers may be exposed to in the recycling process or the manufacturing process. And the recycling process is typically done by very poor people in developing nations that don't have access to personal protective equipment, and there isn't a lot of legislation or regulation around those facilities anyway, so they're not working in good working conditions. All right, so in terms of the learning objectives, we talked about how we get energy from the sun, whether that is PV cells, whether it's concentrated solar power, which is not in the learning objectives, but you guys should know it anyway, whether that is active solar or passive solar, we talked about it. And we talked about the environmental effect, both positive and negative, of solar panels, or sorry, solar energy. Anyway, I hope that you guys learned something, and I will see you all in class.